Part 3, the plane P has this equation here. So we are told to find, we're told to explain why line L lines on plane 3. So in other words, we need to show that L satisfy the plane equation. Okay, that's about it. So you have L1 and plane 3. So part 3. Now the first thing is, what is this plane 3? How? This is P3, right? This P3 is like how to write. This is Cartesian form, right? How do you write in scalar product form? Can we write this down? 2x y p. If this is P3, we need the scalar product form first, right? So this is k minus 1 2x plus 2y plus z minus x minus 2. Okay, so how to write in scalar product form? You expand first. So this is 2 minus k x plus 1 plus 2k. Why? Because in scalar product form, my only interest in changing it to scalar product form for Cartesian form, what I want are just the coefficient of x, y, z and a constant here. Okay, so please don't because it looks different, then don't get scared. Just use the same principle. So P3 will just be r dot to 1k 1 plus 2k 3 plus k equals to 1 plus 2k. Okay, that's how we do it. Then what to do next? Just replace it in. Do you need to change it to scalar product form to show? Actually, don't really need to. You can actually just sub your x, y, z inside here. You left hand side equals to right hand side. Also can, but it will look very, very difficult. Okay, so this you get very complicated lah. But I just want to quickly practice how to write in scalar product form. Sub L into left hand side of P3. Important, because you want to show that when you sub L inside here, so this whole line equation here, when you sub inside here, this whole thing here, it should equals to the right hand side. Okay, when you want to show, you just need to show that it's the right hand side. So here, left hand side. So when I say left hand side is this part here. So this part here, R will be and hope that we get 1 plus 2k. So this will just be a lot of zeros. I like it. Plus k minus 2k 0. Since L satisfy P3, hence okay, there you go. So for the subsequent part, hence or otherwise, find the Cartesian of a plane equation which contains line and a point. Okay, where this point line. So in other words, this otherwise here, refer to page 21. Okay, we've done this before, so I'm not going to talk about the point and the line there. But of course, I will need to explain the hence part. How to do the hence part. Now, you are told that you want a line and a point. Okay, the point 2, 3, 4. Yeah. How do you then find the plane? Now, there are a few things at play here. We know that this line L here will definitely satisfy this. This line L is definitely on this plane tree, right? Okay? Is that okay? Any value K, you will definitely have a plane tree here. Now, this point here, 2, 3, 4, we can also substitute it into this plane equation here. Okay? Now, I repeat, this plane tree will definitely contains L. Okay? But this K here, for a different combination of X, Y, Z, you have a different value of K. So what I can do is I just sub. So for the last part, the hence part, I'm using the hence one. For 2, 3 what? 2, 3, 4, right? I'll just sub X equals to 2, Y equals to 3, and Z equals to 4 into plane 3. Is that okay? Plane 3. Because I know there are infinitely many points on this plane. There bound to be some X, Y, Z which give me a corresponding K. So I'm just going to find this K here. Now, whatever plane I find for P3 definitely will have L on it, one. Okay, so that's the thing there. So what I'm going to do is I'm just going to substitute it into plane 3. I sub into this plane 3 here. This one. This one is already arranged out. So it's 2 plus 3. It's a K. Yeah. Plus K. Okay, there you go. Key calculator. Find out what's the K. Okay, it's actually K is -3. So the plane equation what do they want? They want the Cartesian equation. So the plane equation will just be this one. I'll just use this one. It's plane 3 which you found. Just sub K inside here. Sorry, divided by 5 is 1. Just like that. This is plane equation.